we start at the top with a little reminder that if we're doing multiplication or dividing in an experiment for something like figuring out density, if we have mass and volume and we need to figure out density, we have to divide. Well, we need to take into account the percentage uncertainties as well. And to do that, what we're going to do is add those percentage uncertainties for both of the values that I'm dealing with, or multiple values if that's the case. And then if it's requested of me, I can then figure out the absolute uncertainty. So in my example, I have a value of 581 plus or minus 4. Here's my kitty cat. And then I have a value of 42.0 plus or minus 0.05. And I need to divide those two values to figure out my answer. Perhaps again, I may be dealing with density. So one thing I need to do right away is calculate the value. So I just take my 581 and divide it by my 42.0. I get a value in my calculator of 13.83333333. Now I know that that does not represent the actual values that I get in the laboratory, because I know that my equipment is not that precise. So I need to look at my initial values and think about my Sig Fig rules to determine what my final answer should be. And I see that 581 has 3 Sig Figs and 42.0 has 3 Sig Figs as well. And I'm dealing with the multiplication rule, which means I need the least amount of Sig Figs as my final solution. Well, they both have 3, so 3 is what I'm going to go with. So I look at my first 3 digits in my value, 13.8. I look at the value directly behind the 8 to see if it's 5 or above, to see if I need to round up. However, it's a 3, so I don't need to round up at all. It's just 13.8 as the actual value of the division that I have to do for this experiment. Now I can go ahead and start calculating my error. To figure out the percentage uncertainty, I take 100 times my error divided by my value. And then I need to add that to my other error, or percentage uncertainty. So I take 100 times 0.05 divided by 42.0, my error divided by my value. And I get, from my calculator, 0.807515777. But I know that's not the correct number of Sig Figs. I need to again think of my Sig Fig rules, and I am dealing with the one where I need to do division, and I need my lowest number of values of Sig Figs. So I look at my different values. 4.0, it has 2 Sig Figs. 581 has 3 Sig Figs. 0.05 has just 1 Sig Fig, and 42.0 has 3 Sig Figs. So my least number of Sig Figs is 1. So I have to report my final answer of my percentage with 1 Sig Fig, so it's 0.8%. And I can report my entire final answer as 13.8 plus or minus 0.8%. Trillian really wants to help with the video today. Okay, next I can figure out the absolute error, and how I do that is I take my value, my actual calculated value, and I multiply it by my error divided by 100. So I'm just undoing the percentages that I would normally figure out for percentage error. So I don't want to use my final value, my 13.8 plus or minus 0.8, because I don't want round off errors. So what I'm going to do is go back to the beginning where I had my full calculator values and plug those in. So I have 13.83333333. That's my value, multiplied by my error, which my calculator spit out to be 0.807515777 divided by 100. And I get a value of 0.111706349. And I need to go back to my original values to determine the number of significant figures that I need to report my answer in, because I'm dealing with multiplication or division, so I need my lowest number of Sig Figs total. If I look back at my original problem, the 581 had 3 Sig Figs, the 4.0 had 2 Sig Figs, 42.0 had 3 sig figs, and 0.05 has just 1 sig fig. So I need to report my final answer with that lowest number of 1 sig fig. So I have to say, okay, that 1 is important, 0.1, and I look directly behind that 1 to see if the value is a 5 or greater. It's not, it's just a 1, so I don't need to round up. So my answer is just 0.1. And I would report my complete final answer as 13.8 plus or minus 0.1. Now if I knew actual units, I should write those in. However, this problem did not give me units, so I can't write those in.